the soul. There's a language of life. That's called the DNA. And there's a lot of similarity between music and DNA. What are the similarities? Music is basically made of 7 notes, which are repeated in multiple combinations to form what we know as the tunes. And DNA has got only 4 letters, which are basically the chemicals A, T, G, and C. And these 4 letters are repeated in multiple combinations to form what we call the genes. And similar to how songs are formed from the tunes with the lyrics added onto them, we have the proteins that are from the genes once they are translated. And I'm not a very good player. I do make a lot of mistakes when I'm playing some tune. And when in doing so, sometimes I make mistakes. And these mistakes are exactly similar to what we call mutations in the DNA. In some cases, these mistakes are very similar to the original tune, so it goes almost unnoticed in the song. And something similar happens in your DNA. These are called synonymous mutations because they're very similar. In some cases, these mutations get noticed, really bad. Instead of E, I play a G. Something like this happens, and these are called non-synonymous mutations. In some cases, I play a tune which is not part of the original tune. From some other tune I played in between without realizing, and these are called insertion mutations. And in some cases, I might misplaying the tune, and those are called deletion mutations. In some cases, the worst can happen, like I might do a smaller mistake in the tune that is going to change the beat of the song. And those are called frame shift mutations. And in some cases, I might mess up so badly that I have to stop playing. And those are called truncation mutation. See, there's a lot of similarity between music and DNA. There's yet another similarity. We have what we call chords, which are not actually part of the main tune, but then these add the oomph factor to your music. And we have something similar called the epigenetics. And these epigenetic modifications, changes, are what makes the DNA have its oomph factor. It's not part of the DNA, it's not part of the ATGC. It's a bit different, it's on top, and that's why it's called epigenetics. And I'm trying to study this epigenetics, and what I'm actually trying to study, if I make mistakes in these chords, if there are mistakes that are in the chords, are they affecting the concert's vibe? Is what I'm trying to find out, and that's my PhD project. Thank you for listening. I'm Judith.